Okay, in the lecture we looked at one quality of passive design, particularly with respect to London. That was the quality of heat loss, and how we can address that through some very simple strategies. So we looked very quickly at three different apartments, and we made the point, which I think everybody got, that between these three apartments, A, B, and C, the fundamental difference was, although they're the same size and same shape and same windows, the fundamental difference was how much of those apartments relates to outside, so what we'd say the external facing part of the envelope. And there's both windows and walls. So you may recall what we looked at. Maybe we looked at, say, apartment A. There are two qualities which we need to take into account. One is the area of the windows, which is very simply measured as in width by length to give us a meter squared, and the other is the U value. Now this thing of a U value is a figure we introduced which describes the ability of a material to conduct heat. And you may remember I said that a low number is a low number is good and a high number is bad. So the methodology we're going to do now basically looks at the product of those two numbers, which is the area and the U value together. And we can describe these three apartments in terms of what we might call their heat loss coefficient, which basically means the ability they have to lose heat to outside. So again, apartment A is very good at not losing heat because there's very little wall facing outside. It has a very low heat loss coefficient. Apartment B, which has an additional side wall, if we do the same calculation multiplying the area by the U value of the elements that face outside, we can see that it is a higher heat loss coefficient. That means it's better at losing heat, as in it will get colder in winter. And then finally apartment C, that's the one with a roof on top. That has a much higher heat loss coefficient because, again, if we multiply the area of each surface by the U value of those surfaces, we end up with a much higher number. Okay, so what I've asked you guys to do is to look at your homes with respect to those two criteria. I want to know the area of the walls facing outside, and I want to know the area of the windows facing outside, and I also want to know the U values of both walls and windows facing outside. So that's the first part of this exercise. So I remind you that my home is a typical end of terrace London house. I have a bay window at the front, but I'm also, because I'm in the end of the terrace, I have walls that face outside. They're marked in red. And I also have this curious little box which sticks out the back, which is very cozy, but also loses a lot of heat because it has a roof of its own and it has three external walls. Just to remind you the layout of my apartment, I've a long kind of ground floor apartment, front room with a bay window, bedroom in the middle with a window facing south, and a kind of a kitchen living space that, as I say, is that little add-on unit at the back. So in terms of, I'll go backwards. In terms of the first thing I want you to do is quite simply to work out the area of each of those walls. So it's pretty easy to do, and you might just want to do it with a measuring tape. If, for instance, we take this wall here, this is one wall that I have which faces outside. I've calculated that the area of that wall is 18.8 meters squared. I simply measured it with a measuring tape. I've gone around my whole house measuring each wall, wall 2, wall 3, wall 4. I've measured each of them and basically measured how much area is. Okay, so what I've asked you to do, and I've included in the Dropbox, is there's a Excel sheet. I know probably you're not used to Excel, but just bear with me, it's just easier than doing it manually. So all I want you to do in the first instance is work at every single wall in your house. You may have very few or you may have many, and remember I'm only asking you to look at one floor of your house. I don't want you to do the entire building. And I want you basically to fill in these areas. So I've done this for my home. I know that that wall that I just looked at is 18.8. I've worked at the other one, it's 6.1, and I go around my whole house basically working out the area of each of those walls. Okay, so that's fairly straightforward, and you can do that for windows, depending on how many windows you have, walls, depending on how many walls you have, and roof, depending on if you have a roof, and I have only one small section roof, which is that back room. If, by the way, you want to introduce more columns, if you click and then right click, you can insert as many additional lines as you need to give yourself all of the numbers of walls or windows that you have. Okay, so back we go. That's area. The next thing is U-value. What are these walls and windows made of? Okay, well, it's kind of worth trying to figure it out, and I really encourage you to look at your windows and try and understand the thickness of the wall. Thickness can tell you an awful lot. For instance, this is a picture of my wall. Now, this is a Flemish bond. I don't know, I mentioned this in the lecture. A Flemish bond basically means is that there's a brick on its side, a long brick, and that dimension of a typical London brick is 215, and then a brick the short way round, that's 102.5 in width. But that basically means that that brick is going through the depth of the wall. It's actually, this wall is in depth 215. It's 215 solid brick wall. And that is important for me to know because the depth of the material and also the material itself, which has a certain ability to conduct heat, those two issues are going to give me the U value. Okay, so I want you to have a look, and I want you to also, like I've done, photograph that wall so that you can understand what it is. Now, the website that I've given you is this website. There are many such websites this, but I've just picked this one, and this allows you to understand the U value. So I'm going to click on, just to show you the exercise, I'm going to click on wall. This is the wall I have. I've said that my wall, when I bought this place in 2007, was just solid masonry, so I'm going to pick solid masonry. And then it basically shows me what the wall are, and you just have to make all the selections. So my wall, there is no render on the outside. I'm going to pick none, and I keep going forward, next layer. It is, as I said, it's a solid 215 brickwork wall. I know that because I've measured it. 215, I'm going to pick next layer. Then it asks me various other things, and you may not be able to figure this out, or you may be able to. I know, having taken my walls apart, that there's nothing after my blockwork wall except for plaster. There's a 13mm plaster coat, and that's pretty much it. So I'm going to finish. That's all I had. Now, so it therefore tells me the U value of my wall. So that's the number I'm after, 2.28. And I told you, if you remember, that higher numbers are bad, lower numbers are good in terms of insulation. So 2.28. So I'll go back to my Excel, and then I've now just flipped over a tab. So these are all the areas I figured out previously, and I'm going to now put in the U value as a 2.28. That's what it told me. Another little handy trick if you want to avoid typing. If you just click on the bottom right hand of a cell and drag it down, that will give you the same number repeated. Okay, in terms of windows, I've made your life a little easier. I've just given you the U value numbers for typical glazing construction. So I think you can just go with those. Anybody who's got single glazed, obviously that means if you look at your window, there's only one single sheet of glass. You can go with 5 watts per meter squared Kelvin. Anybody with double glazed, you can assume 1.4. And those of you lucky enough to have triple glazed will be down to 0.7. Just to say, I showed you this photograph, but it's all fairly self-evident if you have a thermal camera, which, by the way, you only have to ask, and there is one which I can rent out. Not even rent, give out, but it's on loan. You can buy. And just, this is a photograph of 2 windows in my home. One is single glazed, one is double glazed. I think it's fairly obvious why one is colder. This is the single glazed one. it is letting out a lot more heat, and therefore it is much colder as a surface, being blue. This is the double glazed one. It is not letting out as much heat, and therefore it is warmer, therefore a different color. Okay, so going back to the Excel, essentially all that I'm going to ask you to do is to fill in the U values. And this is my 2007 flat, so I had single glazing throughout, so everything was 5, and then we're just going to simply fill all of those conditions out. Actually, I didn't have a roof light, so let's get rid of that. Okay, okay, so what we have here essentially is the first part of what I've asked you to do. It's pretty easy to do, to be honest. I've just asked you again to take the area of each window and its U value, and take the area of each wall and its U value, and if you have any roof, then the area of that roof and its U value, which you should be able to get from the other website I gave you. So that gives you a figure of, compared to mine, 276. That was what the heat loss coefficient of my house was in 2007, and you should be able to compare your current U value to my original one. Okay, back we go. So I, of course, insulated my home, as I told you, and I also told you where I put that insulation was very strategic. It was just in terms of external walls, where we had identified we had a source of heat loss. So I would like you to look at insulating your external walls, which you should now know. I think I mentioned to you that, not being a builder, my insulation, I insulated on the inside of my walls, and I wasn't quite as good as I should have been. This, again, using the thermal camera, shows little parts where I either left the insulation out or simply had what we call a cold bridge, something that wasn't an insulator connecting inside to outside. So lots of places which in my home I haven't done very well, and the probably impact of that is that somewhere in that wall there is a cold surface and condensation forming, God forbid. So that's why that's not good. Okay, so let's just do that quickly. The website that I would recommend for you to look at is this Celotex U value calculator. I've given you the link. So if you click here on U value calculator, you can see if you're on target. Celotex, by the way, is a make of insulation. There are many other websites that do this. This just happens to be quite an intuitive one. I'm just interested in walls, so I'm going to click on walls. I said that I insulated internally. There's other ways in which you could insulate, but just to show you the process, let's take internal insulation on a solid wall, continue. And again, there's different ways in which you can fix insulation. I know I fixed mine using a dot and dab is what I used, which is, you can look up dot and dab. And then you're doing a lot of the same things again. We already said I don't have an external finish. We already said I have brickwork, and we said it is 2 and 5. It knows that already. And I know that what I used on mine was 50mm insulation, and of course I had 50mm insulation and then 12.5mm plasterboard, so the total thickness is 62.5mm. I'll pick that. And then I'm just going to calculate it. So let's calculate that. And it has given me a U value of that new wall build. So that basically, remember, low numbers are good, high numbers are bad. So my new U value is 0.34, which is much lower than what I had before. Let's just stick that in. So I'm now going to Giles' flat 2015, and I'm going to 0.34, and that's essentially what I did across every single window. And then I told you that almost all my windows were replaced for double glazing, so the value I've given you for double glazing, 1.4, far lower than the 5 you had previously. And then also my roof, you can figure that out yourselves. I have even more insulation in the roof, so the figure there is much lower. Okay, so all that gives us basically is a new figure, which is The figure currently that my apartment achieves 46.2 in terms of just a coefficient for heat loss. And it's obviously vastly lower than what I had before as a function of what I've done to the walls. Okay, so that's essentially what I've asked you to do. I'd like to know how your apartment compares to my apartment. Right, okay. The thing I want to try you to do is play a little bit. I want to understand how you can have the heat loss in your apartment. You're going to have to do it through a number of ways, but let's assume that you're allowed to play with the windows. You can go from double to triple or single to double glazed. You can expand the insulation. On the Celotex website there are many different ways in which you can increase or reduce the thickness of insulation. I'd like you to look at that, but particularly I want you to make it architectural in terms of, assuming you're insulating your house on the inside, what does that actually mean in terms of your furnishing? Does everything still fit in? I noted, I don't know if you remember, but this room that I have at the back of my home, which I said is a little box that is exposed on three sides, is quite a small room. It used to be the bathroom, I think I told you that. But basically what that has meant is that our furnishing options in this room are fairly limited. We can just about fit a bed in this dimension here, just about. I want you to understand whether the impact in your houses is similar, what it actually means spatially to add this thickness to the inside. And the measure I want, as I say, is to see that you're having the total heat loss from your home. Okay, that's it.